Hello. Okay, so we are doing problem number 8. Yes, 8 today. And number 8, I already drew it out as you can see. But yeah, so number 8 says given us I should probably again, yeah, I am on a new setup because I think it's so much I don't know. Oh, here we go. Because I think it's so much better because I could do stuff like this. Oh my god, I totally, this is so awesome. It's on an infinite scroll, basically. So you have all the room you want. Oh, I should have known about this sooner. So good. So good. I'm recording. I'm so happy. Very happy about this. So problem 8, and it's uh swap nodes, I think. It's like swap. I don't know. Do I have to specify? Just swap. Oh, swap node pairs. There you go. I was like swap two nodes. No, that's not it. Swap pairs. So they have to be adjacent to each other, and that's the problem. Um, 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 um. So you definitely have to draw it out. You definitely have to draw it out in order to solve this. There's just no way. So as you can see, I drew it out first. Um, da, 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 da. So my approach is, oh, let me read it. Given a singly linked list, write a function to swap elements pairwise. For example, the linked list is 1, 2, 3, 4, 5. Then the function should change it to 2, 1, 4, 3, 5. And if the linked list is 1, 2, 3, 4, 5, 6, then the function should switch these two. So it would become 2, 1, 4, 3, 6, 5. I should probably draw that out. So the output that is desired output input should be what's it called? 2, 1, 3, 4. No, not 3. Haha, caught myself. 4, 3. Oh my goodness. 6 and I think 5. Yes. And then 5 points to null. Oops. There's no 3 L's in null. Oh my god, delete, delete. Sorry, my only criticism with this is that I don't have an undo button. I have to click up there in the corner for an undo right here. So I don't have a control Z anymore. I don't know why Google Keep doesn't allow us to have a control Z. This seems, everything else seems amazing. So close, Google, always so close. So yeah, that's kind of our thing. So this is just so I don't even know the brute force way of doing it. Well, I guess I do, but like I didn't think to do the brute force way because I mean it was like, okay, we're gonna need 2 pointers and a dummy node would help because anytime we touch the head of something, it's gonna be very messy to, adjust the pointers with nothing's there. So we definitely are creating a dummy node, dummy head right here. Ooh, it responds to intensity of the strokes. Cool. Do you see how thick that line is? I didn't do that. Oh, I did, but that's so cool. Oh, I should have done this from the beginning. This makes it so much easier to write. But yeah, intense. So I got distracted. I forgot what I was saying. Oh, I'm so excited. Woo, look how beautiful those strokes are. Okay. Oh my goodness. Yeah. I don't even what was I saying? Oh yeah, we need a dummy node because that would help. So strategy wise, we should do 2 pointers, a dummy to help with dirty logic, a dummy head, and yeah, that's about it. It's yeah. Okay. Then we're going to uh I'm just gonna, I think, the code. Um so what I wish I could do, and I guess I can now in this platform, I could just delete this. Look, look how easy that was. I just got rid of them. It just does this. Ah, that's so cool. Look at that. Oh, baby. That's so cool. I could illustrate so much easier now. So cool. Okay, so essentially what we're doing is we want to swap. We have the dummy head node now. We're gonna now swap 2 and 1. And when we're swapping 2 and 1, what we're doing is adjusting the pointers. And that's all we're doing. The nodes are not changing. We are just adjusting the pointers to it. So we need to be very, very careful where we're going to move the pointers. And yes, we're gonna start with 2 pointers. We're gonna have one called prev, and we're gonna have one called current. And prev goes on dummy, and current goes on the first node, and then that's kind of our starting point. And we're gonna increment prev and cur as we go. But now because it gets messy because we have to point 1 to 4 and 2 to 1 and 4 to it could get messy, so we need to save our pointers that we're going to swap. So we're going to save the second node, so the current.next. We're going to save it to the pointer, this pointer. We're going to save it to uh, second, this node called second. And then we're going to save the current.next next because one needs to point to wait, is this recording? Because one needs to point to 4, so it's like it gets messy. We need to anticipate a lot of things. I don't envy the work in the linked list. Always makes me go crazy. It's just so crazy. Yeah, sorry. I want to make sure this is recording, but not in my way. Give me a second. I will adjust. And okay, cool. Okay, so yeah, we are saving we have need to save 2 and 3 because we're going to be adjusting them and we don't want to lose any of them. We're going to move 1. We're going to move current.next, the arrow, yeah, the pointer. So we want to assign these guys saved. And then now now that we have them saved, we have the next set, which is 3, and the second, which is 2 saved, then we could go in with the pointers and start doing the dirty work of reversing them, and that's what I circled before. I guess I could circle in a different color. Yeah, let's try orange. Okay, so this is the pointer pointing the second dot next. And the second dot next is going to, if I remember correctly, current? Current? Oh no, it's current dot next. Wait, what am I doing? I drew this out before you saw it. Now I don't remember what happened. Why? Why my brain tripping? Yeah, okay. It's going here. I don't know. It's going here. And current dot next, which is this guy, points to 3. Yeah, so it wants to go here. Because it wants to go to 3, and then prev dot next, which is this one, the next of previous, is going all the way to second. And this will eventually, believe it or not, result to our swap. I really wish I did this better because this is it's hard to explain. I watched some YouTube tutorials and I'm like, oh, I'm glad I'm not the only one who's just like having a hard time explaining this without visual whatevers because I draw it and it's just arrows all over the place. I'm like, that's not any better than just me saying it. Um, I don't know how to do this right. Oh my goodness. But it goes to second. So it's like, okay, the pointer and second dot next goes to essentially the current. I mean, there should be still dummy here, but obviously we're going to return it without the dummy. We're just going to go, prev dot next or something. So we're going to return it without dummy, but technically this is not lost because there's dummy in front of it, and that's why the dummy is there. And so yeah, so 2 is going to 1, and then 1's going to be next to 2. Or like after 2 instead before 2, because we're going to 3, and then 1 is going to push. It's going to go to next set. Next set is 3, but it hasn't been reversed yet, so we'll get there. Eventually, it'll point to 4, and prev.next, which is the pointer pointing to 1, will now point to 2, like here. It started at 1, now it's 2. So it's reversed. And then all we have to do now that it's reversed is to update the pointers and kind of increment prev and cur to um, the next set. And the next set would be moving. Let me choose color. Moving. I don't know. I'm just gonna stick with black. Would be moving pre. So we're moving 1. So this. I will delete this later because it's gonna confuse me. So this becomes the new prev, and current becomes the and current becomes this thing, I think. Yeah. The current dot net. So current is going to become, sorry, it took me a while. Current is now going to be pointed to the next pair, because we need to get the next pair to reverse because we're done with this one. Hence why I was like confused. I was like, whoa. So I was right. So you go to this guy right here, that we saved, so that it could, since we reversed these two, now this is the next set, and we reverse these two, and then this would go the same for this, and that's what the updated pointers do. And yeah, that's that. I'm gonna delete all of these random arrows because they do not make it easier for me. And this is better. It's too much. So now let's write up the code. Is there a way I could zoom out on this? Okay, you know what I'm gonna do? I'm gonna shrink everything. So I was recording a video yesterday. I got so caught up in explaining that I actually was late. I was late to the interview, which is really not good. So, but that's how much energy I was putting in, just because I really was like into this explaining this problem. Actually, I'm not sure. I think this is all the room I need, so I don't need to make it too small. But I'm just saying how amazing that I get to do this. Now I don't have to like erase things. I could just like shrink them. Oh, this would have been so good for the LRU cache problem. And so many problems. It would have made it such a better and easier job to explain and write without messing up and feeling bad about it. Oh, so happy. Yes, look at it. It's beautiful. I was wondering, like, how did I draw on this? It's not the tablet. I mean, maybe it's a little bad. It's a little old, but it's this recording. It's the whiteboard itself. It's just this one has something built in to sense, intensity of pressure and stuff. Like, it was so slow. I didn't know. This is so good. I love it. It is a joy to now write on this. So we're going to swap pairs. Oh wait, what am I doing? we're not gonna do a class because it's just a pseudo. I mean, it's just a quick code. Okay, so we're going to go with head. Okay, now we're gonna start a dummy, as I explained before. That is equal to the head, and then we're going to go previous pointer. We're going to create prev and a current, and then we're going to go, okay, prev, you become dummy, and current, you are head. And yeah, okay. Oh, I already noticed my own typo. Here we go. I was like, wait, what? I caught that pretty quick. Okay, so dummy is this node 0, and yeah, so cur is head, and cur is what is being used to go traverse the list. And we're starting out at the dummy head with prev. So yeah, that looks in order. So we're gonna do a while loop because we don't know how long this loop is. I mean, this linked list is. Dot next equals, so this is saying while current and current dot next is not none, or is not null. We're going to what was I saying? Yeah, we have to save the pointers in orange. So we're gonna go next set equals current dot next dot next. You know, when I was first learning about linked lists, I thought that was the most confusing thing ever. I was like, what is current dot next dot next? Now it's like, okay. And then second is current dot next. So we're essentially saving these nodes or pointers in a different variable. Yeah, we're saving these pointers in different variables so we could swap them without losing them. And now we're going to go, this is the reversal. I'm going to write it in orange or something. Reversal. Because this part is quite, actually, this is really confusing if I write it like that. It looks like it's part of the code. It's not. But whatever. I'll just say this is the part of the reversal. I'm gonna put it in the orange box because I can. I'll put it in the orange box to remind myself. Current dot next equals cur. So we're adjusting the pointers now, and cur dot next is next set, and prev dot next, which is the dummy pointer pointing at 1, originally now goes to 2. Okay, cool. This is the reversal error. This I'm drunk. I don't know. This is terrible. You know what? I don't care. There's there's nothing here. Don't look. And then now we're gonna update the pointers. So we could, it's because it's very important to move on to the next pair that we need to reverse and increment everything. And now I believe I made this too big. I lose a little more grip control when it gets to the bottom of the page. Sorry guys. To cur equals next set. That just means that we are incrementing it. So reversals this part and then incrementing the nodes. Sorry, not nodes. The pointers are here. Okay, and then we're just gonna do a simple return. We could. Oh yeah, we return dummy. So we just return dummy.next. Yeah. and we write it outside, and this will return, and that's the code. Okay, cool. That's it. Oh, I think I have to discuss runtime. So there is no additional. So we use two pointers. So we didn't use any extra space. So space complexity is space is constant. Um, and isn't it? Yeah, and runtime. I mean, for the time complexity. Time complexity is um, linear time, so n. And because we are using double pointers, we're traversing once. We are like changing up the pointers a lot, but we are only making one uh, transversal through the array, or through the linked list. Sorry. Yeah. Okay, that's it. Oh yeah, I'm done.